When I started learning Python, it really surprised me how verbose it is to define even simple classes. Something like a spaceship class needs a declaration, an init function, and then some more code just to store the variables. That's a lot more effort than a language like C, where the same class uses a lot fewer characters. Well, Python actually does have a more concise way of defining classes, and it's called the data class. In this tutorial, we'll use a data class to recreate our spaceship example, and also look at some features that you might not know about. To create a data class, we first need to import the data class decorator from the built-in Dataclasses module, and then apply this to a class declaration. Then we can add in the inputs we want to store as individual attributes, along with some default values. Let's also add some type annotations for better readability, and now we've made our first data class. You can immediately tell that this is a lot less code than a normal class, but this conciseness is just the beginning. Data classes also implement something called Dunder Methods. These are essentially double underscore functions that change the default behavior of a class. For example, when you print out a regular spaceship instance, we'll see the memory location and not much else. The data class version, however, prints all of its attributes. That's because data classes automatically implement the repr dunder function. This method changes the string representation of the class to show all of its attributes, making it much more readable. Another useful Dunder method data classes implement is the equals function, which determines whether or not one class instance is equivalent to another. This is useful because normally comparing two separate instances of the same class returns false, even if they have the same values. It might seem weird, but that's because Python compares their memory locations instead of their attribute values. Generally, this isn't what we want, and so we typically end up writing our own equals dunder that compares the attributes individually. With data classes, however, we get this for free. So if we compare two separate data class instances, we'll get true as long as they have the same values, even if they are in different memory locations. Now let's say we want to go beyond equality and also sort the spaceships by their name. We can't do this with regular classes since they don't implement the less than greater than dunder functions. With data classes, if we set order equals true in the decorator parameters, we'll auto-implement these missing dunder methods. Now, if we call sorted on a list of spaceship instances, we can sort them by their attribute values with no additional code. The data class decorator also offers some other useful options, such as the ability to freeze a class via frozen. If we create an instance with this option enabled, modifying class attributes raises an error, and we can stop users from accidentally changing things that they shouldn't be. Finally, one slightly more advanced feature about data classes that's useful is their ability to have mutable default arguments. For example, we might want our spaceship to have a cargo attribute that's a list of items it carries, with the default being an empty list. If we were using a regular class, we need to have additional code that uses the isNone idiom to assign a new list dynamically. With the data class, however, we can import a special function called field that lets us specify a factory function to build the default argument. For example, for an empty cargo list, we can say default factory equals list. Now, whenever we create an instance, we'll automatically build an empty list by default. It's clear that data classes are a useful tool in Python, and if you want to learn more about them, be sure to check out the Python 3 documentation in the description below.